In this lesson, students will be able to state why it is important to include the unit of measure when stating the weight of an object. Let's start with some vocabulary. A gram is the standard metric unit for measuring mass or weight. A kilogram is equivalent to 1,000 grams and is used to measure heavier items. We're going to start with a problem. Eric has a penny, a nickel, and 2 quarters in his pocket. A penny weighs 3 grams, a nickel weighs 5 grams, a quarter weighs 6 grams. How much do the coins weigh altogether? I'm going to show you some different strategies that your child might come up with to solve this problem. The first is a physical model. If you have a scale that measures in grams, you can stack the coins and actually weigh them. Or if you have a scale like this, you could put the 4 coins on one side and put the gram weights on the other side until they balance. So in Eric's pocket, he had a penny, a nickel, and 2 quarters. Way off balance now. So on this side, it looks like it's going to be pretty heavy. So I'm going to start with 10 grams, and it hardly moves it. So I think I can go with a heavier weight and go with 5 grams. Oh, it's starting to move. So let's try 2 grams. So we've got 17 grams now. Here it goes. And let's put 2 more grams. 19 grams, but not quite. It's perfect. So Eric has 20 grams of coins in his pocket. The next strategy is draw a picture and write an equation. I have a penny, which is 3 grams, plus a nickel, which is 5 grams, plus a quarter that's 6 grams, and another quarter that's 6 grams. And when I add that up, I have 3 plus 5 plus 6 plus 6 equals 20 grams. So that's one equation. Or since there are 2 quarters, I can write it 3 plus 5 plus, in parentheses, 2 times 6 equals 20 grams. So Eric has 20 grams of coins in his pocket. It's very important to label the answer. If the answer was written simply as 20, anyone reviewing the problem would not know what the 20 meant. It could be coins, grams, kilograms, or watermelons. The third strategy is a bar model. The weight of the coins is represented by the entire box. Since there are 4 coins, I divide my bar into 4 sections. Since the numbers are different, I adjust my lines to show which is smaller and which are greater, to help me visualize the problem clearly. Then I put the numbers in the boxes. Since the 4 boxes are filled, it shows me that I have to add the numbers together to find out how much the coins weigh in all. So again, 3 plus 5 plus 6 plus 6 equals 20. The fourth strategy is to write an equation. Since I know that there are 2 quarters, I'm going to write 3 plus 5 plus, in parentheses, 2 times 6 equals 20 grams. With any strategy you use, you get 20, so your answer would be 20 grams. Let's look at an open-ended problem. Open-ended problems may have several answers or many ways of solving them. Let's take this problem. Davis is working hard to be healthy. He has a goal to be able to lift 30 kilograms. If each week he works to lift 3 additional kilograms, how many weeks will it take him to reach his goal? The problem is asking how many weeks, so my answer will be the weeks, not the kilograms. First, students should consider how much Davis should be able to already lift. Can he already lift 3 kilograms, 12 kilograms, 0 kilograms? When students solve the problem, they should explain what Davis was already lifting before he set his goal. The answers will be different if the starting weights are different. Students could use any of the above strategies. I'm going to choose that Davis could already lift 6 kilograms and draw a picture to help me solve it. I start with 6 kilograms, then add 3 kilograms, which equals 9, then add 3 more kilograms, which equals 12. Since I'm adding 3 each time, I can now start counting by threes. 15, 18, 21, 24, 27, and 30. It took 8 circles to equal 30 kilograms. So if Davis could lift 6 kilograms at the beginning, it will take him 8 more weeks to reach his goal. Notice that I wrote 8 weeks, so nobody would think I meant my answer meant kilograms. It's important to label your answer correctly to avoid any confusion. If I wanted to show another strategy, I could write an equation using my picture with repeated addition. 6 plus 3 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 equals 30. I noticed that there are 8 threes, so I could write the equation 6 plus, in parentheses, 8 times 3 equals 30. In this lesson, students were able to solve problems using different strategies. They were able to understand the importance of including a unit of measure when stating the weight of an object.